Hi to you watching this video. So for this video, we're going to discuss about module number 10, Hydrographic Survey. So this module will give you an introduction to hydrographic surveying in relation to hydraulics in computing the cross-sectional area of a channel and or reservoir in computing hydraulic discharges. Okay. So what is hydrographic surveying? So hydrographic surveying is the process employed in gathering information concerning any body of water and its adjacent land areas. Okay, so for example, you have here your team that is conducting the survey, and this is the equipment. You have here the equipment attached to the boat. Okay, so you have here the dynamic transducer draft correction because this is the surface of the water and this is where your the machine is attached. Okay, then there is an observed depth, and you have here the sound velocity correction. So this is the site. Next would be the tide of correction. Why is it tide of correction? Tide of correction because we know that we have high tide and low tide. Okay, and if it is a low tide, then there comes our reference datum, and this is our actual depth from the surface of the water up to the bed. Okay, then we have here the chart depth from the datum up to the water bed. Okay, or for the bed. Okay, so what is the purpose of hydrographic survey? So we have here, it is being used for hydrographic maps and nautical charts. It is also used for flood control, water supply, and hydroelectric power development irrigations. It is also used for elevations, for designs of bridges, drainages, sewages, and culverts. Volume of impound water. You also have here tidal datum, and it is also being used as hazards for hazards such as submerged obstruction, sunken vessels, sandbars, rocks, shoals, coral reefs, and etc. Okay, so hydrographic surveying in relation to hydraulics. So I believe by now you should already finished, or I am not sure if this is no, yeah, you should already by now be finished with your hydraulics. Okay, so what is hydraulics? Just a recap: hydraulics is a branch of science and engineering focusing on the properties of water and other fluids and uh, analyzes as a moving fluid, so also known as dynamics of fluid. So discharge, or Q, is known as the volumetric flow rate, or it is simply yeah, the volume which is moving. Okay, so volumetric fluid. So Q is equivalent to volume over time. It can be in meter cube per second. It can be also in cubic feet per second. Yes, so meter cube per minute, meter cube per hour, it can be that. But the important thing is it is volume per unit of time. Okay, so measurement of stream discharge. So measurements of stream discharge are usually made in connection with design of water supply system. Okay, I repeat, measurement of stream discharge are usually made in connection with the design of water supply system, flood protection works, hydroelectric power development, irrigation system, and fish farming structures. So these are the factors that needs to be considered in making and determining our stream discharge, because these are the essential things that are being produced or are being used for the water or by the water. So kailangan natin i-consider 'yan. So another also we need to consider in constructing of bridge, stream discharge, and yeah, kailangan natin i-consider 'yun kasi we need to determine or we need to know that it is above the maximum level of discharge so as to avoid na mag-submerge yung bridge natin sa water pag nagkaroon ng uh, f- um, pag umakyat yung water level sa river natin or kaya sa dadaanan ng tubig. That's why it is important for us to determine the stream discharge. Okay? And also another thing that we need to consider sa stream discharge, sabi dito is water supply system. Water supply system, it is uh, we know that dam is one of the major source where we get our water supply for domestic purposes. Okay, for drinking purposes. Yan, dam. Next would be the flood protection works. So we also need to determine the stream discharge so as to avoid flooding. Okay, so if ever man ma-reach natin yung maximum, at least na-avoid natin na magkaroon ng flooding. In hydroelectric power development, because we need this just volume of the discharge so that we can compute the power that is being generated. Irrigation system, it is the water that goes through our agriculture and fish farming structures. Okay, so it is also important to determine the maximum discharge of a stream when estimating size of culverts and waterways areas needed under some structures. It is very important, I repeat, it is very important to determine the volume because we want to avoid flooding. Okay? Ayaw natin na magkaroon ng flooding, and the last thing that we want to do is we want to see or want to happen is someone has died because of drowning due to flooding. So we need to determine the maximum discharge in order to estimate the correct area for the cross-sectional area, for the cross-section of our design. Okay? Para yung dadaanan ng tubig is ma-maximize natin, hindi magkakaroon ng overflow. Okay? So the principal information sought in a discharge measurement is the volume of water flowing past a measuring section of a stream in a given period of time. So the discharge of streams, ditches, flumps, canals, and other waterways is expressed in cubic meter per second. Cumix, or we can call it cumix. Okay? Cubic meter per second. Okay? Discharge measurements are made on several occasions at times of low, average, and flood stages. A single discharge figure is seldom useful. In the analysis of an engineering problem, a discharge measurement only becomes effective after it is combined with several other measurements made at the same section at various stages. Accurate knowledge of stream flow can only be obtained if regular observation are made. So, we need to consider environmental factors. So hindi pwedeng nag-inspect ka na ngayon or you had your observation today, then that's the absolute data. No, it can happen that iba yung data na makukuha mo during typhoon season, iba rin yung data na makukuha mo during summer season. Okay? So it is the correct data is being determined through a constant observation, okay, or regular observation. So methods of determining stream discharge. So letter A, you have the velocity area method. So the velocity area method of measuring discharge is commonly employed in channels and rivers. It consists essentially of making observations of velocity at selected depths on several verticals and subsections along a line transverse to the direction of flow. The result is quite accurate since the cross-section of the entire flowing body of water is divided into several smaller subsections. The velocity at each subsection is determined separately and multiplied by its area, and the sum of this product gives us the total discharge of the whole cross-section. So for the velocity area, isn't it that Q is equivalent to velocity times the area? Okay, so the velocity is meter per second and the area is meter squared. So if you're going to multiply the velocity times the area, it will be meter cube per second, thus giving us our Q. Okay. Next would be the slope area method. So for the slope area method of determining discharge is usually primarily for obtaining the peak flow. Okay, it is the peak flow of the stream after the stage has receded. When we say peak flow, it is the maximum flow a discharge could reach. Okay, a straight stretch of river of uniform slope and cross section is required. So dapat yung slope natin dito is constant because we need the slope and the cross section is also constant all throughout a certain length. So the fall and the distance between the points of the points at which it is measured should be sufficiently great that the inclination can be determined without serious error. The survey work involved includes the determination of areas of cross sections at each end of the ridge and the slope of the water surface in the selected ridge during the peak stage. It can also be called it will also call for selection of coefficient of roughness. So I believe you are quite familiar with the coefficient of roughness, no, from our hydraulics based on the physical characteristics of the channel. Okay. So the results obtained by this method are approximately are inferior in precision to those in which the velocity is actually observed. So the limitations of this method lie in the difficulty of selecting a correct value of roughness coefficient and in measuring the flat slopes with precision. However, this method is useful in making tough estimates of flood discharge in stream and open channels. So if we want a precise measurement for the velocity, itong method na to, this will give us a precise or accurate data compared to the slope area method. But if it is very difficult, no, very difficult to use this method, then we use this method for rough estimate. Okay. Next would be the determining of the velocity of approach. So the velocity of approach, it is the velocity up at the approach. Okay. So we have here the Chassis formula for open channels with Cutter's coefficient is generally used. So it is V is equivalent to C times the square root of RS. Okay? By substituting to the discharge equation, substitute natin yung velocity, isn't it that Q is equivalent to VA? Now we substitute V, we therefore have area times V, and the V is C times the square root of RS, where Q is the discharge of the stream, V is the mean velocity of the stream, A is the mean cross-sectional area of the ridge, C is Cutter's variable coefficient or Cutter's coefficient, R is the hydraulic mean depth or hydraulic radius. When we say hydraulic radius, it is the wetted perimeter. Okay? S is the longitudinal slope of the water surface. So it is a unitless value. Okay? So for Cutter's coefficient, it is a variable whose value depends principally upon the roughness of the bed and also upon the inclination. So, and the hydraulic mean depth. In practice, the value of C is commonly derived tables or diagrams based upon the formula of Cutter and Gaungele, which is expressed as following. So, these are very important formulas, V, Q, and C. So C is equivalent to 1 over N plus 23 plus 0.00155 over S over 1 plus N over the square root of R times 23 plus 0.00155 over S. The roughness coefficient in the above formula is a retardation factor that will depend on the character of and slope of the stream bed. Okay? So a straight and clean channel will have a low value of N. Okay? So habang nagiging irregular yung channel natin, tumataas yung value ng roughness coefficient natin. But if it is a straight and a clean channel, ang roughness coefficient natin becomes lower. So for example, the value of N varies from 0.02 for irrigation canals with a well-trimmed bed in perfect condition to 0.035 for canals with very bad order with a lot of weed and stones. So there are many other materials present. So they are adding factors to our N. So for streams where the banks in the bottom are very smooth, pag smooth naman yung ano natin, yung bottom, it is 0.03. And when the banks and the bed are especially rough, it is 0.04. The selection of the end value for a stream calls for exercise of personal judgment. So if you're quite experienced already in the field, or kung may kakilala kayong experience na sa field, then it is his or her judgment to determine what would be the best value of N. Okay, so for those who do not as yet have the necessary experience, a hydraulic handbook should be referred to when estimating the value of roughness coefficient. So that would help us a lot in determining the value of our N. Okay. So the hydraulic radius is determined by dividing the cross-sectional area of the stream R by the wetted perimeter or length of the bed under the water. The wetted perimeter, mali pala na sabi ko kanina. It is R is not the wetted perimeter. It is the cross-sectional area over the wetted perimeter. Okay, clarify ko lang. It is the cross-sectional area divided by the wetted perimeter. And that is R. The wetted perimeter is the actual length of the line, the water cross-section, when the water and the ground are in contact. Okay? So, in the formulas of Chesi and Cutter, S is the longitudinal slope. So, S is the longitudinal slope or inclination of the water surface. So, it is determined by dividing the fall in the measured distance by the horizontal distance. Okay, so I believe somehow you already know how to determine the S given a problem. So both the fall and the length should be expressed in the same units. The slope is measured by careful leveling and should be determined on each side of the stream and at the center. Since the center slope is usually steeper than the sides, the average slope is used. So i-average natin sila. Okay? So in shallow streams, a graduated rod is held about 30-meter intervals along the middle of the stream, and rod readings are taken from the shore with the level. And observed elevations are plotted on paper, and the mean slope is determined from the plotted elevations. In large streams, the slope of the stream bed is approximated by measuring the slope of the stream surface. Okay? So, yeah. So that would be the step. And next would be the capacity of lakes and reservoir. So in the design of water supply system, when we say water supply system, it is the system that is supplying water to areas, for example, a residential area, urban area, from our reservoir. So from the reservoir to the water, to the end consumer. That is a water supply system. Irrigation projects, structures for aquaculture development, hydroelectric power generation stations. It is necessary to determine the volume of water which could be contained and generating by a supporting reservoir or lake. So this is the biggest factor actually. So gaano karami yung kayang i-contain ng reservoir. Okay? Because that would determine how many water can be supplied by the reservoir or by the dam. Hindi porket dam, hindi lang dam yung pwedeng maging water supply. Pwede rin na you also have your lake. Lake can also be a water supply, and it can be considered a no, it cannot be considered a dam unless we have a dam structure. Okay, but it can be considered as reservoir. Okay? But normally, ang mga ginagawa nating dam is yung kung saan nagpo-flow ang water, and like what we have said in our contour, magpo-flow ang water sa lowest elevation. And sa lowest elevation, normally, it is a river. So, yung river, nilalagyan natin ng dam. Nilalagyan natin ng gates. Okay? Then from there, nilalagyan natin ng structure na magiging dam. And yung dam ang nagre-release ng water. Then from there, from the opening of the dam, doon natin dinedetermine yung ating discharge. Okay? So, when the streams emptying into a reservoir or lake is silt-laden, periodic surveys are necessary to determine the remaining effective capacity for water storage. Okay? Next would be the methods in determining the capacity of lakes and reservoir. So, cross-section method. So, cross-section method is commonly used when a moderate degree of precision is required. Take note, moderate degree of precision is required in determining the effective capacity of a body of water. It is well suited in the survey of lakes and reservoirs with a uniformly defined cross-section. Again, uniformly defined cross-section and where a reference baseline could easily be established along the shore and parallel to the center of the length of the body of water. Okay? So this is the top view. If we are to imagine, ito yung top view. Then at this area, okay, so this area, ito yung kanyang cross-sectional area. So ito yung lalim niya. So this is the water surface. Ito yung itsura ng ilalim. Okay? Now at this line, at this RCL, itong RCA, wala tayong depth because nasa dulo tayo ng reservoir. Dito tayo sa RLB, we have this. So dito sa RLC, this is the water surface. Ito yung itsura ng ilalim. Ito yung waterbed. So ito yung itsura ng ilalim. Then yung sa taas, that would be water. Next sa RLD, ito yung level ng water surface. Then ito yung ating ilalim. Okay? Then we get the area. We cut it into different polygon. Then from there, we determine the area and we add them. Okay? So D is the horizontal distance between the cross section. RL is the range of line perpendicular to the baseline. A is the area of cross section which is determined by soundings. And V is the volume prismoid between any two sections. Okay. So in this method, the following steps are performed. Lay out parallel ranges across the body of water at selected points. And the range lines should be established as nearly perpendicular as possible to the reference baseline. Take soundings at various points on each other of this range, where the bottom of the lake or reservoir is fairly regular. The spacing of the sounding on each range may be uniform or may be not. Sounding, however, may have to be taken as nearly as possible at significant changes in the slope of the bottom. In shallow areas, sounding may be performed with the use of sounding rods and by wading through the water. A sounding line released from a small boat is used in deeper sections of the lake. When the length of a range line is significantly long, the process of locating soundings by stretching a rope may no longer be feasible. Other methods of locating soundings should be employed. Determining the area of the cross-section on each several parallel ranges from the soundings, the horizontal distance between the soundings. So, ang gagawin natin, for example, this is the water surface. Okay? Then, we already know how the profile of the bed looks like. So, hahatiin natin siya in such a way na makakabuo tayo ng polygon. So, dito, we were able to create a triangle. Then from this point to this point, almost uniform yung slope. Dito kasi nagkaroon ng change of slope. So it is better if we cut it here so that we can still create a polygon, three-sided polygon. Then from this point up to this point, constant yung slope natin. So we can create here a trapezoid. Likewise, with D5 to D4, yung slope natin is constant. So we can also create here another trapezoid. from D4 to D3, makaka-create tayo ng square. Constant yung ating slope. From D3 to D2, constant yung slope, so we can create a trapezoid. Then we also have from D2 to D1, we have a constant slope, so we can create another trapezoid. And from D2 to RWE, we can create a right triangle. Then we get the individual area of this polygon, then we add them. Then we already have our area. Okay? So, yeah. So for this typical cross sections, the area of each partial section is determined as follows. Okay? So this is simply simple math. Okay? So 0.5 d times L1, because that is a triangle. This one is a polygon. So we have here d6 plus d5 over 2 times L6. Okay? So yan. Okay. So I hope somehow pag nakita nyo yung picture, you know how to get the area, because this is just triangle. This is just a trapezoid. So kunin natin yung individual na area, then ipag-add natin. Yun na yung total cross-sectional area. So ganun yung ginawa. Individual area, then ipag-add, then we get our total area. Then for the volume, we multiply the depth. Okay? Yeah. So for the area, pinakita natin dito sa ating solution, it is d1 plus d2 over 2. So tama, d1 plus d2 over 2 times the length of I2. So that would give you the area times the length. Now to get the volume, i-multiply nyo sa depth. Okay, so sa depth nito. Anyways, we will see this in the problem. Okay, you don't need to memorize the formula as long as you know how to determine the volume. Okay, there's no need to memorize the formula. So by the volume, the entire body of water can be determined by adding the partial volume of the volumes of the general prismoids, into which the body is assumed to be divided by the cross sections. Okay? So kinuha na yung individual volume, then pinag-add. Next would be the contour method. So for contour method, the elevation of the water surface is determined by leveling from the benchmark. So we have a benchmark, or our point of reference. So on a prepared map of the reservoir lake, the subaqueous contour are then plotted from the surrounding elevations, covering the area below the water surface. The area enclosed by the water line by each contour is determined by the use of planimeter, or by counting full, and partial squares as enclosed by the contour when plotted on cross-section paper. So the average of the enclosed area at two consecutive contours multiplied by the contour interval, or vertical distance between them, gives the volume of water lying between the two contours. So this is actually similar to computing the volume of prismoid. Okay? So for that, we use the formula for contour method. V is equivalent to H times the quantity AL plus AH over 2, where V is the volume of the prismoid, or the volume of any two consecutive contours, where H is the contour interval, or the vertical distance between two consecutive contours. So it is the vertical, not the horizontal. AL is the area enclosed by the lower contour. AH is the area enclosed by the higher contour. Okay? Then the total volume of water contained in the reservoir or lake is the sum of the volumes of the prismoid. So ipag-add lang natin yung mga volume ng prismoid. So in general, the approximate volume can be computed using the formula. So this is the general formula. V is equivalent to AO over 2 plus AI plus AH, where AO is the enclosed area enclosed by the boundary of water surface at the water surface. AI is the sum areas enclosed by all intermediate contours considered, and AN is the area enclosed by contour at lowest level. AO, water surface. AI, intermediate contours. AN is the contour at the lowest level. So having into consideration all of the things that we have read, we are now ready to solve for the problems. Okay, so we have here the illustrative problems. The right and left water edges of stream are 3.0 to 32 meters. So from 3.0 up to length 32 from an initial reference point. So this is our initial reference point. So verticals are located at distances 5.5, 5.5, 8.5, 11.5, and so on, going to the left. Okay, so we were also given the depth. So the mean depth of 0.6, 1.2, distance depth 3, d4, d5 up to uh, the left end section. Okay, so we were also given the mean velocity of each section. So we have the mean velocity at section 1, 2 until the end of the section. So assuming that the discharge in the end section of stream to be 0, determine the following. A, the cross-sectional area of the stream. B, the discharge of the stream. And C, the average velocity of flow of the stream. Okay, so for the first one, we need to determine first the cross-sectional area. Okay, so for this one, what we're going to do is we're going to consider it as if it is a trapezoid. Okay, so we are going to consider it as a trapezoid. Okay, so in getting the area, it would be half of 2.5 because we started here, our section 1 is here, half of 2.5 plus half of 3 times the depth. Okay, so that would be the area. So that would be, let's say that is area 1, it is equivalent to 2.5 plus 3 over 2 times the depth of 0.6. Okay, next, area 2, we have, for the area 2, it is half of 3 plus half of 3. So 3 plus 3 over 2 times the depth of 1.2. Next, for the area 3, we have half of 3 plus half of 3. So 3 plus 3 over 2 times the depth of 1.4. Next, area 4 is equivalent to half of 3 plus half of 3 over 2 times the depth of 2.4. Next, for area 5, we have the same, half of 3 plus half of 3 times the depth of 2.6. Then we have area 5, we have the same for 5, 3 plus 3 over 2 times the depth of, area 6, 2.7. Okay. Next, for area 7, we have 3 plus 3 over 2 times the depth of 2.5. Then area 8, we have half of 3 and half of 3. So that is 3 plus 3 over 2 times the depth of 2.0. Then we have area 10, which is equivalent, area 9 rather. Area 9, we have half of 3 plus half of 2.5 divided by 2 times a depth of 0.9. So we can now solve for the area, the cross-sectional area. So we have 2.5 plus 3 over 2 times 0.6, we have 1.65 square meters. Then, palitan na lang natin yung ito, no, 2.5 na 3. Then, palitan natin yung ating height. That is 3.6 square meters. Then, 1.4. That is 4.2 square meters. Then, palitan natin. Let's change that. 7.2 square meters. Then, 2.6. Wait. 1.4. 4.2. Okay. So, 2.4 we have 7.2, 2.6 we have 7.8 square meters. 2.7, 8.1 square meters. Then 2.5 we have 7.5 square meters. 2 we have 6 square meters, and 0.9 we have 2.7 square meters. Okay, therefore the total cross-sectional area is equivalent to 1.65 plus 3.6 plus 4.2 plus 7.2, 7.8 plus 8.1 plus 7.5 plus 6 plus 2.7. That is equivalent to 48.75 square meters. Okay? Now, to determine the partial discharge in each section, take note, magkakaiba yung ating velocity, mean velocity on each section. Okay? The next thing that we need to do is to determine the velocity on each of these sections. So, we have a different velocity on each of the section. Therefore, magkakaiba rin yung ating discharge. Iba yung area natin, iba yung velocity. Therefore, the discharge would be the same. Okay, so yeah, we need to solve for the discharge of each section. So let's say we have here Q1. So we have here Q1 is equivalent to area 1 times V1. So what is area 1? 1.65 times velocity 1, which is 0.2. Take note, it is meter squared times meter per second. Okay? So Q2 is equivalent to 3.6 times 0.5. Q3 is equivalent to 4.2 times 0.7. Then Q4 is equivalent to 7.2 times, for the 4, it is 0.9. Then you have Q5, 7.8 times 5, we have 0.9. Then Q6, we have 8.1 times, for the 6, which the velocity is 1. Q7 is equivalent to 7.5 times the velocity of 7, which is 1.1. Then Q8 is equivalent to 6 times 2. Okay? No, 0.6 rather. 0. So 6 times 0.6. Then Q8. Then Q9, we have 2.7. Area natin, 2.7 times a velocity of 0.2. Okay? So we can now solve for the value. So 1.65 times 0.2, that is 0.33 cubic meter per second. 3.6 times 0.5, that is 1.8 cubic meter per second. 4.2 times 0.7, That is 2.94 cubic meter per second. 7.2 times 0.9. 6.48 cubic meter per second. 7.8 times 0.9. That is 7.02 cubic meter per second. 8.1. Definitely, this is 8.1 cubic meter per second. Then, 7.5 times 1.1. That is 8.25 cubic meter per second. 6 times 0.6, that is 3.6 cubic meter per second. 2.7 times 0.2, 0.54 cubic meter per second. Okay? So therefore, we can now compute for our Q total. So Q total is equivalent to 0.33 plus 1.8 plus 2.94 plus 6.48 plus 7.02 plus 8.1 plus 8.25 plus 3.6 plus 0.54. 1.8. Okay, so that is equivalent to 39.06 cubic meter per second. Okay, so that is letter B. Now for letter C, we need to determine the V average. Okay, so Q total is equivalent to area total times the V average. So cross multiply or divide both sides by area total. V average is equivalent to Q total over area total. What is the Q total? 39.06 cubic meter per second divided by the area total of 48.75 meter squared. So cancel. Ang matitira is meter per second. So 39.06 divided by 48.75. That is 0.801 meter per second. That is the average velocity of this cross section. Okay? So number 2, given the following data for a stream of uniform flow, area is equivalent to 6.97. It is the average stream cross section. Okay? So P, or the wetted perimeter, is 9.76 meter. S, or the slope of the stream bed, is 0.007. And N is equivalent to 0.25, roughness coefficient. So assuming that that a constant stream bed slope and little variation in the cross section and condition of the bed, determine the following. Letter A, hydraulic radius. Letter B, average velocity of the stream using Manning's coefficient and the corresponding discharge. And letter C, the average velocity of the stream using Cutter's coefficient and the corresponding discharge. Okay? So for letter A, hydraulic radius, it is simply R is simply equivalent to the area over the wetted perimeter. And the area is equivalent to, what is our area? 6.97. So 6.97 square meters divided by the wetted perimeter, which is 9.76 meter. So meter and meter will cancel out. So we will be left with meter. So 6.97 divided by 9.76 is equivalent to 0.714 meter. And this is now our hydraulic radius. Okay? Next is letter B. So for letter B, the average velocity of the stream using Manning's coefficient. So for velocity, the average velocity, V is equivalent to C times the square root of RS. Okay. Now for letter B, what we're going to use is the Manning's coefficient. So C here is equivalent to R raised to 1 over 6 divided by N. So substituting the value of R, we have 0.714 raised to 1 over 6 divided by N. N is 0.025. Okay. and that is equivalent 0.25. Okay, so 0.714 raised to 1 over 6 divided by 0.025, and that is equivalent to 37.816, and that is our C. Now substituting the value, we can now solve for V. V therefore is equivalent to C, which is 37.816 times the square root of R. What is R? 0.714 times S. What is S? 0.007. So 0.007. And velocity is therefore equivalent to 0.007. That is equivalent to 2.673, and that is meter per second. Okay, now if we are to get the Q, though ang hinihanap lang sa atin is the average velocity, let's try to solve na rin for the Q. Q is equivalent to velocity times the area. Our velocity is 2.673 times the area of 6.97. So 6.97. Okay, so that is equivalent to 18.634 cubic meter per second. Next is to get the average velocity of the stream using Cutter's coefficient. Okay, so we have the same formula for the velocity. So for letter C, V is equivalent to C times the square root of RS. Okay, so for Cutter's C, it is 1 over N plus 23 plus 0.00155 divided by S divided by 1 plus you have here your N over the square root of R times 23 plus 0.00155 over S. Okay, so these values are readily available. So what we need to do is to simply substitute the values. So 1 over N, 1 divided by the value of 0.025 plus 23 plus 0.00155 divided by the value of S, which is 0.007 divided by 1 plus the square root of times 0.025 divided by the square root of 0.714 times 23 plus 0.00155 divided by 0.007. So the value of C is equivalent to 1 over 0.025 plus 23 plus 0.00155 over 0.007 divided by 1 plus 0.025 over the square root of 0.714 times 23 plus 0.00155 over 0.007, and C is equivalent to 37.475. Okay, so substituting, V is equivalent to 37.475 times the square root of 0.714 for the R, and for the S it is 0.007. Therefore our V is equivalent to 2.649 meter per second. And for the Q, we know that VQ is equivalent to velocity times the area. So we have the velocity of 2.649 times the area of 6.97. And the Q is equivalent to 18.466 cubic meter per second. Okay? So that is the volume. So hindi naman masyado nagkakalayo. Okay? Considering the area. Okay? Okay, so we have here number 3. In the accompanying plot, the boundary of water surface of a reservoir is shown by a regular outline. So A, B, C, D, E, F, G, H. Okay? So soundings were taken on parallel ranges B, H, C, G, D, F. Okay? For the purpose of determining the volume of water in the reservoir. The numbers on the plot show the horizontal distances, which were measured for locating the ranges in the soundings. Also, the depth, which were measured where soundings were taken. Calculate the following. Letter A, area of the cross section. So the cross section of HB, section HB, the cross section of GC, and the cross section of DF. Assume that the cross section areas of range 8E are negligible or nearly zero because this is starting point, this is the end point. So kumbaga walang patag na yan. Okay? Letter B, volume of water between ranges. So the volume of water here, the volume of water here, the volume of water here, and the volume of water here. And letter C, the total volume of water contained in the reservoir. Okay? So, okay. So, for the area of HB, HB area is equivalent to, okay, so isa-isahin natin. Let's consider this small sections here. Okay? So, area 1, baka paano tayo malito? That is the next problem. So, area 1, area 2, area 3, area 4, and area 5. Okay? So, here, we're going to consider this as a as a triangle. Okay? So, for area 1 is a triangle, so it is 0.5 or 1/2 times the height of 1.8 times the base of 3. Okay? Next, for area 2, that is equivalent to a trapezoid. Let's consider it as a trapezoid. So that would be 1.8 plus 3.6 divided by 2 times a span of 4.6 meters. Okay, so that is for area 1. Now for area 3, that is again a trapezoid. So that would be 3.6 plus 3 divided by 2 times the span of 5.8. Okay, next for area 4, 1, 2, 3, 1, 2, 3. Next, area 4, that is equivalent to 3 plus 1.2 over 2 times the span of 2.5. Then area 5 is equivalent to 0.5 because that is a triangle times the depth of 1.2 times the span of 2.5. Okay? So, isolve na natin yung mga area. So, we have here 0.5 times 1.8 times 3. So, this is 2.7 square meters. Next, for the trapezoid, we have 12.42 square meters. Then we have 3.6 over 3 times 3 over 2 times 5.8. We have 19.14 square meters. 3 plus 1.2 plus, no, times 2.5. So that is 5.25 square meters. Then 0.5 times 1.2 times 2.5. And that is equivalent to 1.5 square meters. So, yeah, so do it on your own to get the area for GC and FD. Okay, so isosolve na natin para hindi masyadong consuming sa time. Okay, so ito na siya. The area for CG, so you have here triangle, trapezoid, no, square. So, wait, GC. Yeah, ito. Triangle, trapezoid, square, trapezoid, trapezoid, triangle. Then we have here triangle, square, trapezoid, trapezoid, and triangle. Okay, so we need to determine the total area. So for the total area, no. That's yeah, total area for each section. Okay, so area total, and area total. Now for the area total, we have 2.7 plus 12.42 plus 19.14 plus 5.25 plus 1.5. So this is 41.01 square meter. Okay. Next, we have 6.45 plus 19.11 plus 21.45 plus 39.895 plus 24.475 plus 15.695. And that is equivalent to 100, wait, may kulang. Okay, so tama siya. The area total is equivalent to 127.075 square meters. Now, for the last section, we have here 27.145 plus 51.85 plus 42.34 plus 29.89 plus 13.76. And that is equivalent to 161.985 square meter. Okay? Correction, not 161 but 164. Okay, so that is the total area. Now we can now determine the volume between the ranges. Okay, so how are we going to do so? For the volume between the ranges, so this is the first range, this is the second range, this is the third range, and this is the fourth range. Now for letter B volume. Okay, so volume 1, we have the area of the first plus the area of the second cross section, and that is area HB, 41.01, divided by 2 times the length of 11 feet, or 11 meters. And that is equivalent to 41.01 over 2 times 11. And that is equivalent to 225.555 cubic meter. Okay? Now for the volume 2, is the area here plus here divided by 2 times 13. So area HB is 0.01. So that is 41.01 plus the area of CG, and that is 127.075 divided by 2 times the length of 13, and that is equivalent to 41.01 plus 127.075 over 2 times 13 is equivalent to 1,000, wait, are we yeah, so 1,092.553 cubic meter. Next would be volume 3. Volume 3, that is the volume of CG, which is 127.075, plus the volume of DF. So the volume of DF is 164.985 divided by 2 times the span of 16.5. So, yeah. So, 127.075 plus 164.985 over 2 times 16.5. Yes, so that is 0.5. Okay, 16.5. And that is equivalent to 2,409.495 cubic meter. Next would be volume number 4. So volume number 4 is the area here times the area here. So that is equivalent to 164.985 plus the area here at E, so that is 0, divided by 2 times the span or the length of 14.6, and that is equivalent to 164.985 divided by 2 times 14.6. That is 1,204.391 cubic meter. Okay, so that is the volume. This is the volume of in between ranges. Okay, and lastly, the total volume of water contained in the reservoir. So roughly, the total volume is equivalent to 225.555 plus 1092.553 plus 2409.495 plus 1204.391. And ilan yon? 225.555 plus 1092.553 plus 2409.495 plus 1204.391. And that is equivalent to 4,931.994 cubic meters. So that is the approximate value of the volume of the reservoir. Okay? Okay, so we have here problem number 4. So the area bounded by the water line of a lake and the contours 1, 2, 3, 4 are as follows. So area 1 is 10,250 square meters. Area 2 is 8,350 square meters. Area 3 is 7,750 square meters. Area 4 is 6,100 square meters. And Area 5 is 5,200 square meters. Now, if the contour interval is 2 meter, calculate the volume of water in the lake in cubic meter using the end area method. Okay, so let's try to draw a contour. So for example, you have here a lake. Okay, so there are 5. So 1, 2, dapat closed yan, 2. Then we have 3, 4. And lastly, we have here for the 5th contour. Okay, now what we're going to do is try to imagine how it would look like. Okay, so for this is the lowest part. So let's try to project it so that we can imagine. But if you can already go right away with your solution, then well and good. But if not, it is better for us to draw our profile. So this is our contour map. So what I am doing is the edge. Okay, so I am trying to show you the cross-sectional view. So assuming this is the lowest point, then next would be, because they have an interval of 2 meters, then 2 meters, 2 meters, and 2 meters. So it should be, I know, it should be aligned. Next, we have it here. And lastly, we have it here. Now, if I am to connect that, most likely it would look like this. Okay. Wait, may na-skip. Wait. It should be, yan. Okay. So, Yan. So, pag connect natin yung lines, more or less, it would look like this. Okay? And they have a difference, no, hindi naman exacto kasi meron pa tayong space. Okay? So, the difference between the contour, the elevation, the difference between the elevation of the contour is 2 meter. This is also 2 meters. This is also 2 meters. This is also 2 meters. So 1, 2, 3, 1, 2, 3, 4. And lastly, we have it here. 2 meters. Okay? So that's already the bottom. Okay? So the next thing that we're going to do is to determine the volume. So parang yung ginawa natin kanina sa example number 3, we have volume 1 is equivalent to the area. What is the area of this point? The area of this point is, let's say this is A1, this is A2, this is A3, this is A4, and this is A5. So area 1, so that is 10,250 plus the area 2, which is 8,350 divided by 2 times the elevation difference of 2. Okay? Next, volume 2, that is equivalent to the area 2. What is area 2? 8,350 plus the area 3, 7,750 divided by 2 times 2. Okay. Next, for volume 3, we have area 3, 7,750 plus the area 4 of 6,900 divided by 2 times 2. Next, we have volume 4, which is area 4, 6. Ito yun, area 4 minus area 5. Okay? So, we have here 6,900 plus 5,250 divided by 2 times 2. And lastly, we have area 5 and minus the bottom. So that is 5,250 plus 0 over 2 times the difference in elevation, which is 2 meters. Itong mga 2 meters na to, these are the difference in elevation. So, ganito ang itsura nung natin. Is it lake? Yeah. So, this is how our lake looks like, more or less. Okay? Wait, saan na yun? Ayan. So, no. This should be a straight line, no? Straight line. I just showed you the elevation. This is the top of the water. Okay? Yan. So, to begin, definitely, yung sa ilalim. Okay? So, since the difference in elevation, tapos, yung pag-add and pag-divide natin sa 2, magka-cancel out yung 2. So, we can simply cancel out the 2's here. So, we will be left with volume 1, 10,250 plus 8,350. That is 8,600 cubic meter. Then, 8,350 plus 7,750. That is 6,100 cubic meter. Then, 7,750 plus 6,9. That is equivalent to 4,650 cubic meter. Then, 6,900 plus 5,250. That is equivalent to 12,150 cubic meter. Then, 5,250 divided by nothing. 1. That is equivalent to 5,250 cubic meter. Now, to determine the total volume is equivalent to 18,600 plus 16,100 plus 14,650 plus 12,150 plus 5,250, and that is equivalent to 66,750 cubic meter, and that is the final answer.